Hello everyone, a very good morning all of you and a very warm welcome to you all to this wonderful session of fluid mechanics. Please guys do join me fast, and those who are already here, respond me through the comment section if my audio and visual quality are fine. So that this session is all about the fluid mechanics questions which had been asked in Engineering Science 2024 paper. As I have been telling you from long back that if you are preparing for GATE examination, then solving the previous year question papers for Engineering Science, GATE Mechanical and Civil is always helpful for improving your fundamentals of the fluid mechanics. Even if you are not appearing for GATE examination, then the session or these questions are going to help you a lot in improving your fundamentals, in improving your understanding of the subject of fluid mechanics. So this session is common for civil as well as mechanical engineering students who are going to appear for various competitive examination in the near future. All right. So I will discuss each and every question in detail which had been asked in engineering science paper. So please do let me know if my audio and visual quality are fine so that we can start without any delay. Before I start, let me quickly introduce myself. My name is Chandrasekhar. I am mechanical engineering graduate from IIT Delhi. Also cleared engineering services examination. Worked in Steel Authority of India Limited for a couple of years, and from last 10 plus years or more than 10 years, I have been into teaching, guiding the students who are preparing for various competitive examination, and these are my favorite subjects of mechanical engineering. This fluid mechanics is common for civil as well as mechanical, right? If you are not part of my Telegram channel yet, please do join me on the Telegram, which is Mechanical by Chandrasekhar. The link is also there on the screen. This year in 2024, the fluid mechanics question had been very simple, not only in GATE examination but also in engineering services as well as XC paper. So I am very happy that all the questions were framed from the notes I have shared with the students, or from you can easily relate. Those of you who have studied fluid mechanics from me, they can easily relate. The questions had been framed from only those areas which we always believe to be important, which we have discussed very often, quite a lot of times in the various sessions, various classes. All right. So before starting the discussion of the question, there is an important announcement. On 28th of February at 7:30 p.m. there will be an interactive workshop on BYJU'S exam prep app, which is taken by Richa ma'am. She is MTech from NIT Raipur, having more than 5 years of teaching experience, and she will discuss how to prepare for GATE 2025 with the college or with the job, right? So if you are preparing for GATE 2025 or 2026, this session is going to be very important, and it is free of cost. You just have to register yourself. The link to register yourself is already there in the description box. And if you have not liked this session, please, it is my humble request, please do like and share to all your friends, all your colleagues who are either mechanical engineering students or who are civil engineers and preparing for various competitive examination. This was question number 1. For an immersed neutrally buoyant body. What is neutrally buoyant? People have had a doubt in understanding this neutrally buoyant. If the density of the body, immersed body, if it is less than density of the fluid, then the body will be called as floating body. The body will float. If the density of the body is equal to density of the fluid, then it is called as neutrally buoyant or suspended body, completely submerged. suspended body. If the density of the body is greater than density of the fluid, then the body will not attain an equilibrium. It will be called as sinking body. That we have already discussed in our sessions. So for an immersed neutrally buoyant, it means completely submerged body. Neutrally buoyant means completely submerged. And in equilibrium. That is the meaning of neutrally buoyant. Completely submerged and the body is in equilibrium. To be in stable equilibrium. For a stable equilibrium for a completely submerged body, the short trick I have already told you, I have always told you, is BAG. BAG. So the center of buoyancy must lie above center of gravity for the stable equilibrium for a submerged body. So the center of gravity of the body must lie below center of buoyancy. Option D is correct. Meta center comes only in case of a floating body. The concept of meta center always comes only in case of a floating body. So C and D cannot be correct. It is option B which is correct. The next question, it was a little tricky actually. R is the position vector, V is the velocity vector, and N is the mass, respectively, in a control mass system. Which of the following properties is considered as conserved extensive property in Reynolds transport theorem? What is Reynolds transport theorem? Reynolds transport theorem is the connecting link between the system approach and the control volume approach of analysis. There are two approaches. RTT is the connecting link between the system approach and control volume approach that we have discussed in fluid kinematics. System approach can also be called as Lagrangian. It can also be called as Lagrangian approach. हाँ साहिल क्या पूछना चाह रहे हैं? 2 watt इलेक्ट्रिक स्कूटर कंपनी ओला टीवी, इनका स्कोप है एक्चुअली. दे आर हैविंग वेरी गुड स्कोप बिकॉज ऑफ दिस ग्रीन एनर्जी. दे आर गोइंग टू हैव द फ्यूचर. Lagrangian approach and the control volume approach is also called as Eulerian approach. We use Eulerian approach in our fluid mechanics analysis. In Lagrangian approach, that is with respect to space, and Eulerian approach is with respect to time, right? So in Lagrangian approach, a fluid particle is taken and its behavior is analyzed at different sections. But in case of Eulerian approach, a fixed section is taken in space, that is called as control volume, and the behavior of the particles passing through this section is analyzed at different time instant. This is the difference between system approach and Eulerian approach. And according to Reynolds transport theorem, rate of change of angular momentum in control volume. What is the Reynolds transport theorem? Rate of change of angular momentum in control volume is equal to rate of angular momentum transfer. From system boundary. So the question was not that difficult. Rate of change of angular momentum in the control volume is equal to rate of angular momentum transfer across the system boundary. If you read the question clearly, which one of the following properties is considered as the conserved extensive property in Reynolds transport theorem to obtain the angular momentum equation? We obtain the angular momentum equation by using this rate of change of angular momentum in control volume is equal to rate of angular momentum transfer from the system boundary. So the conserved property is angular momentum. Conserved property is angular momentum. What is the angular momentum? R cross linear momentum. Or we can say R cross mass into velocity vector. This is the property which is conserved. The conserved extensive property is r cross mv, that is the angular momentum. That is angular momentum. So this is the conserved property. Option A is correct, right? The third question again was very simple. Consider the velocity u, v, w in x, y and z direction respectively. The vorticity expression in yz plane. In yz plane, vorticity will be about x-axis. It is the angular velocity. Vorticity about x-axis is given by, that is del y minus del z. The velocity component in z direction will be the numerator of the first term, del w. The velocity component in y direction will be the numerator of the second term, del v. So this will be the expression. Very simple. It is formula only. Del w by del y minus del v by del z will be the vorticity in x direction or about x-axis. Vorticity in yz plane is about x-axis. That is the vorticity about x-axis. I hope this is clear. The question number 4 was again very simple. For incompressible laminar fully developed flow through a circular pipe, Darcy's friction factor and Fanning friction factor. I have told you multiple times, Darcy friction factor we use notation F, and Fanning factor is also known as friction coefficient. Fanning friction factor is also known as friction coefficient. Generally we use the notation F dash. So the Darcy's friction factor is 4 times of friction coefficient or 4 times of Fanning friction factor. So F is the Darcy friction factor, CF is the Fanning factor. The relation is F is equal to 4CF. It will be 4CF, option A, very simple. And I hope you guys are already aware that we are starting the atomic series on the YouTube channel for BARC 2024. As the BARC examination is coming near and we want all of you guys to prepare thoroughly for the BARC examination, because you are having one more opportunity to join the BARC either through GATE, or if your GATE did not went well, then there is another opportunity. You can appear for this examination and get selected in this prestigious organization. The series is starting from today only, and do subscribe our Byjus YouTube channel so that you get the information notification for all the sessions which we will bring in this BARC series. All right. Question number 5, again 1 mark MCQ. For the laminar incompressible flow over a flat plate with uniform free stream velocity, the axial pressure gradient within the boundary layer is, do you remember del P by del X is equal to 0 when the plate is kept parallel to the flow? When the plate is kept parallel to the flow. So when the flow is parallel to the plate, then the pressure gradient will be 0, or we can say P is not a function of X. It will be remaining constant in the direction of the flow. So the axial pressure gradient, dP by dx is pressure gradient, axial means in the flow direction, is equal to 0, will be equal to 0. Alright, clear? Let us move to the next question. The locus of, again MCQ 1 mark, the locus of the temporary locations. These are the simplest possible question which GATE can ask in fluid mechanics, right? The locus of the temporary locations of all particles that have passed through a fixed point in the flow field at a particular instant. That is the definition of a streak line. Streak line is the locus of fluid particles at any instant. Fluid particles at any instant which must have passed through a fixed point. Through a fixed point. I must have given you an example. If you fire some rounds of bullets from a gun, if you fire round of bullets from a gun, the gun bullets are traveling like this. So this path is called as streak line. the locus of all the fluid particles which must have passed through a fixed point. This is the fixed point, and the locus is like this. This is called as straight line. Question number 6, option A. The hydraulic diameter for a circular pipe. For a pipe, the hydraulic diameter DH is equal to D only, that is twice of R. For we do not calculate the hydraulic diameter for a circular pipe because it is same as actual diameter. What is the formula for hydraulic diameter? For non-circular pipe, we use the concept of hydraulic diameter, right? DH is equal to 4A by P. If it is circular pipe, 4 into pi by 4 D square into P is pi into D. If you do this calculation, then DH will be equal to D. For circular pipe, it will be D only. Very simple. And we are running the ground zero series for GATE 2025 and 2026 aspirants on our BYJU'S exam prep app also. If you have not downloaded the exam prep app, then you can download it from the Google Play Store, or you can find the bit.ly link in the description box. After the class, please do not forget to go through the description box. There are so many important links which are there in the description box. So you can download the app and start attending these sessions of ground zero series where we discuss the each and every concept in a detailed manner so that the concept become more simple and easy to understand. Question number 8, NAT 1 mark. Very simple. The absolute pressure in a chamber is measured as 400 mm mercury. That is the absolute pressure at a location where the atmospheric pressure is. This is atmospheric pressure, 700 mm mercury. They have not even changed the unit. Both are given in pressure head of mercury column. A vacuum gauge connected to a chamber reads. Vacuum gauge, it means it is measuring the negative gauge pressure. So we can say absolute pressure is equal to atmospheric pressure, that is local, plus gauge pressure, which is with sign. So gauge pressure is equal to absolute minus atmospheric. Absolute is 400 minus 700 millimeter of Hg. So it is minus 300 millimeter of Hg. Because it is a vacuum gauge attached. Vacuum means negative gauge pressure. Vacuum means negative gauge pressure. So the reading will be 300 millimeter of mercury. The reading will be 300. Yes, Vinith, well done. Good. I wanted the students to give me the answer. Yes, that will be more interactive, more beneficial, more interesting. What about the question number 9? Everybody, please give it a try. Question number 9. Again, simple question, yet there is a slight twist. People might have thought of option A, because if we draw tau versus du by dy, this is how dilatant fluid is drawn. This is how pseudoplastic. And the slope is and this is how the Newtonian fluid. This is Bingham. The slope of the curve will be the viscosity. Now for pseudoplastic, if you see, viscosity decreases, slope decreases. It is about the pseudoplastic fluid. So viscosity decreases as du by dy increases. The curve is between viscosity and du by dy. Here you can see viscosity is increasing. In first figure, viscosity is increasing with increase in du by dy. It cannot be correct. Here viscosity is constant. That is for Newtonian fluid. That is also incorrect. Here also viscosity increases. Option D says viscosity decreases. This is the curve this will be the curve for dilatant. This will be the curve for dilatant. Right? D आएगा. Well done. No का D आएगा. What about question number 10? Now the questions have started for 2 marks. A little more time taking, but yet they are still simple. Consider the steady incompressible flow of water. The fluid is water. In a horizontal pipe of constant diameter, diameter is constant, here also D, here also D. Constant diameter 1 meter, and the value is also given as 1 meter, very simple value, with an inlet velocity of 12 meter per second, that is V1. Let me call it as V1, let me call it as V2, and let me call it as V3. As shown in figure, water is lost through a circular hole of diameter 0.6, so D3 is given as, at the rate of this is Q3. The discharge is given. The outlet velocity is, we need to find out the value of V2. So we can say from the continuity equation, the question is from the continuity equation, Q1 is equal to Q2 plus Q3. Discharge entering into the control volume is equal to discharge leaving. The discharge is leaving from Q3 as well as Q2. So we can say Q1 is A1 V1 is equal to A2 V2 plus Q3. The objective is to find out V2. So what is A1 V1 is pi by 4 D square into V1 is equal to pi by 4 D square into V2 plus Q3. So it will be V2 is equal to, can you solve it? Very simple. If you divide by pi by 4 D square, if you divide the entire equation by pi by 4 D square, then V1 is equal to V2 plus pi by 4 D square. So 4Q3 upon pi D square. So V2 is equal to V1 minus 4Q3 upon pi D square. Because Q3 is given, so it will be V1, that is 12 minus 4 into 4.53 upon pi. D is 1. That will give you the answer meter per second. What will be the answer? Yes, the answer will be 6.23. Are you getting 6.12 minus 4 into 4.53 by pi? 6.23 will be the answer. Well done, Vinith. Good, good, good. Keep it up. Single question bhi tough nahi tha. There was not a single question which was tough in this. तो इसलिए बहुत लोग इंजीनियरिंग साइंस को सीरियसली नहीं लेते, बिकॉज दे हैव द दिस माइंडसेट that because in engineering science paper is having some extra syllabus, and because there is less number of opportunities through engineering science paper, and we need to work some extra harder. But after the GATE had given you a chance to apply for 2 papers, then it is always helpful for the students to appear for engineering science paper other than your main paper, whether it be mechanical engineering or civil engineering, because there are a lot of opportunities and it is very, very simple to score full out of full marks in the engineering science paper easily. Iska answer, what is the answer? Consider again, the question is from the Bernoulli equation, NAT for 2 marks. Consider the incompressible steady and irrotational flow. It means ideal flow. The flow is ideal through a concentric reducer in a horizontal. This type of question had been asked in GATE previously. Bernoulli equation and continuity equation. Yes, that's it. 7.9 तो गलत लग रहा है. विनीत, क्वेश्चन नंबर 11 अभी बताता हूं. क्वेश्चन नंबर 11 आंसर शुड बी 7.91. वेल डन. The answer will be 7.91 kg per second. The pipeline reduces from D1 12 centimeter to D2 4 centimeter. The pressure at position 1 and 2 of the reducer P1 is 55 kilopascal and P2 is 27 kilopascal. The specific weight of the fluid. Here also people commit the mistake. The specific weight or acceleration due to gravity is 10. So density of the fluid is 700 kg per meter cube. Do not skip this part. Now neglecting the frictional effect, the mass flow rate. What is the mass flow rate? Can we write rho into A1 into V1? Density is 700 and A1 we can easily calculate pi by 4 D1 square. The only problem is to calculate V1. So using the continuity equation, what is the continuity equation? A1 V1 is equal to A2 V2, or we can say D1 square into V1 is equal to D2 square into V2, because D1 is 3 times of D2. So V2 will be 9 times of V1, isn't it? V2 will be equal to 9 V1. That is what we will get from the continuity equation. This is equation number 1. We are finding the velocity V1. And if we apply the Bernoulli equation, because Z is constant, there is no change in potential energy. If we apply Bernoulli equation, so we can say P1 plus rho V1 square by 2 is equal to P2 plus rho V2 square by 2. Or we can say rho by 2 V2 square minus V1 square is equal to P1 minus P2. What is P1 minus P2? 55 minus 27 into 10 to the power 3. Put the value of V2. So we can say rho 700 by 2 into 81 V1 square minus V1 square is equal to 28 into 10 to the power 3. Right? So V1 square is equal to 2 into 28 into 10 to the power 3 upon 700 into 80 under root, sorry, V1 will be this, under root of this. Do the calculation. 0, 0, 0 getting cancelled out with 10 to the power 3. This will become 4. So root 1 is equal to 1 meter per second. V1 is 1 meter per second. So the mass flow rate is density into pi by 4 d1 square into V1. Density is 700 into pi by 4. d1 is 12 centimeters, 0.12 square into 1 kg per second. पूरे पेपर में यही क्वेश्चन थोड़ा लेंथी था, लेंथी भी इतना नहीं था अगर आप स्टेप बाय स्टेप करें. डोंट कैलकुलेट V2 unnecessarily. Develop a relation between V1 and V2 and use the Bernoulli equation in terms of pressure. In terms of pressure. तो ये छोटी छोटी चीजें अगर आप करेंगे then you will get the answer quickly. The answer to this question is 7.91 meter per second. Because it was carrying 2 marks, that is why it was supposed to be a little tough or little lengthy, not tough. The next question, question number 12, again NAT for 2 marks. Consider 2 parallel plates separated by a distance of 1 centimeter. The gap between the plates filled with the Newtonian fluids of viscosity 10 to the power minus 3 Pascal second. Unit will tell you whether it is dynamic or kinematic viscosity. The top plate is moving with a velocity of 1 meter per second, whereas the bottom plate is stationary. The shear stress, it should not have carried 2 marks. It should not carried 2 marks. The top plate is moving with the velocity v. The bottom plate is fixed. Because there is no mention of the velocity profile, we can assume the velocity profile to be linear. We can assume the velocity profile to be linear. So tau is equal to mu into du by dy is equal to mu into v by h, because u as a function of y is assumed as linear, right? So mu, dynamic viscosity, is given into velocity 1 upon h 1 centimeter into 10 to the power minus 2. So 10 to the power minus 1 or 0.1 Pascal will be the correct answer. Simple Cout flow का डायरेक्ट क्वेश्चन है. यस, और वी कैन से न्यूटन्स लॉ ऑफ विस्कोसिटी का डायरेक्ट क्वेश्चन है. This question is also very direct. This type of analysis we have done. We want to find out the force exerted by the jet in normal direction. This is, let us say, normal direction. According to Bernoulli principle, whatever the velocity here is same as the velocity after impact. Velocity before impact is same as velocity after impact according to Bernoulli principle. Because there is no change in potential energy, there is no change in kinetic energy. This is our control volume. So, the force exerted in normal direction is mass of the fluid striking the plate per second into change in velocity in normal direction. Initial velocity in normal direction is v minus final velocity in normal direction is 0. In normal direction, final velocity is 0. So rho into pi by 4 d square into v square will be Fn. This is the formula, rho a v square. Put the values, you will get the answer. Rho is, it is water, 10 to the power 3. You are supposed to calculate in Newton into pi by 4. What is the diameter? Diameter is 50 mm. Sorry, 50 mm. So it will be 0.05 square pi by 4 d square into V square. V is 18, so 18 square Newton. If you will do the calculation, your answer for question number 13 should have been 636.17. Rho AV square, 636.7. 2 decimal तक लिखना है तो 17, 636.17. It will be 17, right? That will be the answer. Question number 30. Question number 14. Again, very simple question. But if you are not comfortable with the basics, fundamentals, then you might end up committing mistake. If you will try to use the direct formula, that is where people commit the mistake. How? Because the velocity profile is not given by the Byjus equation. It is not a Byjus equation. It is not a Byjus equation if you clearly see. Consider the incompressible fluid flow over a flat plate with a free stream velocity of 1 meter per second. The fluid kinematic, they may not have used the word kinematic viscosity because the unit will tell you whether it is dynamic or kinematic. Kinematic is given because meter square per second is the unit of kinematic viscosity, and density is also one. The velocity profile is given by this expression, where boundary layer thickness is given by this. The local wall shear stress, tau naught, wall means tau naught at x is equal to 1 meter from the leading edge into 10 to the power minus 3 will be in Newton per meter square or Pascal. So we need to find out the Reynolds number at, so what is the formula for Reynolds number? Can we call the local Reynolds number to be U infinity x by kinematic viscosity? At x is equal to 1 meter, Reynolds number is equal to U infinity is 1 into 1 upon 10 to the power minus 6. So 10 to the power 6 will be the value of Reynolds number. Right? So for this, if we find out du by dy at y is equal to 0, so it will be 3 into u infinity by 2 into delta, isn't it? And delta will be this. So from the Newton's law of viscosity, tau is equal to, or tau naught is equal to mu into du by dy at y is equal to 0. So mu into 3 by 2 u infinity by delta 4.64 x upon under root of rex. This is the expression. Mu can be written as density into kinematic viscosity. So at x is equal to 1, tau naught is equal to density into kinematic viscosity. Density is 1, kinematic viscosity is 10 to the power minus 6 into 3 by 2, u infinity is 1 under root of 10 to the power 6 upon 4.64 into 1. That will be the answer in Pascal. So if you simplify, this is 10 to the power 3, this. So 10 to the power minus 3 into 3 by 2 into, sorry, this will be 1.5 divided by 4.64 Newton per meter square or Pascal. So this is the value we need to calculate. 1.5 divided by 4.64. 0.323. It will be 0.323, isn't it? 0.32 will be the answer. 0.32. I hope this is clear. This is how. No need to memorize the formula, and the formula will not give you anything. If you are comfortable with the concept, then you can easily develop the relationship. And not only the ground zero series, we are also running post-gate guidance sessions for different IITs, cutoffs for different IITs as well as the NITs, and we are giving you an idea for the expected cutoffs for the PSUs, so that accordingly you can fill up or you can make a right choice as per your gate score. This was the only question which I found a little tricky, and rest of the questions were not even up to the standard of gate examination. Question number 15. A thin film of incompressible Newtonian liquid, density is rho, viscosity is mu, with a uniform thickness h. Uniform thickness h is flowing down on a vertical plane. The fluid is flowing down a vertical plane. The flow is driven by gravity alone. Assume zero shear stress condition at the free surface. So at y is equal to, y is the direction normal to the flow. At y is equal to h, tau is equal to 0, or du by dy is equal to 0. This is how the velocity profile. This is the velocity profile. U as a function of y is given. ये क्वेश्चन भी अगर एक्सी के एक्स्ट्रा टॉपिक्स कौन सा है वो एक्स्ट्रा टॉपिक विनीत? The maximum velocity is given by, the maximum velocity is definitely free stream velocity, u infinity. The maximum velocity is u infinity. The question is to find out u infinity. So if we can develop a relation between u as a function of y, if we can develop a relation between u as a function of y, if we assume it as linear, if we assume it as linear, then we can say tau is equal to mu into v by h, or u infinity by h, isn't it? If we assume it as linear, and tau is equal to tangential force per unit area is equal to mu into u infinity by h. What is tangential force? That is the weight. M into g. Pi area is equal to mu into u infinity by h. What is m? Mass is equal to density into volume. Volume of the fluid is a into h into g upon area is equal to mu u infinity by h. अगर आपने ऐसे किया, so from here u infinity is equal to rho g h square by mu, ये आता rho g h square by mu, which is not correct because it is not given as linear. The velocity profile अगर linear assume करते, velocity profile को अगर linear assume कर लेते तो आपका आंसर B आता, which is not correct. Look, how to develop the velocity profile? To develop u as a function of y. Our objective is to develop the relation between u as a function of y for the given situation. Look, if we use, no need to use the concept of, or the concept of the extra syllabus. Navier-Stokes equation we always talk about in our basic fluid mechanics also. We use Navier-Stokes equation in x direction. If we apply Navier-Stokes equation in x direction, what is Navier-Stokes equation? Net force is equal to mass into acceleration. Navier-Stokes equation is nothing but the Newton's second law. Provided we use the pressure force, net force includes the pressure force, gravity force, and this viscous force. In Navier-Stokes equation, we use pressure force, gravity force, and viscous force. And the same Navier-Stokes equation can be reduced to Euler equation when we ignore the viscous forces, right? Are you getting it? So if we write the Navier-Stokes equation in x direction, the left hand side is minus del p by del x pressure force plus rho into gx, because there is a gravity force is there, there is a viscous force is also there, plus mu into del square u by del x square plus del square u by del y square plus del square u by del z square. That is the left hand side, the net force. This is the net force is equal to density into acceleration. What is the acceleration? Let me write here. Is equal to acceleration in x direction ax is equal to rho into ax. And what is rho into ax? It is del u by del t local acceleration plus u into del u by del x plus V into del U by del Y for 2D flow. This is the expression for Navier-Stokes equation. Because the flow is parallel to the plate, flow is parallel to the plate, P is not a function of X, del P by del X is 0, this term will be 0, and U is a function of Y only, U is not a function of X or Z, this term will be 0, this term will be 0, right? U is not a function of time as well, U is not a function of X, so this term will be 0, V is equal to 0, V is equal to 0, there is no flow in Y direction, V is equal to 0, so this term will also be 0. So our expression will be rho into G plus mu into del square U by del X square is equal to 0. This is our modification to Navier-Stokes equation. Are you getting it? Or we can say del square U by del X square. We can say del square U by del X square is equal to minus rho G by mu, minus rho into G by mu. If we integrate this once, then del U by del X is equal to, sorry, del U by del Y, my mistake. Here it will be Y. Here it will be Y. Okay, यहाँ मैंने mistake कर दी ना. ये this will be 0. This will be 0. U is not a function of X. So this will be 0. So del U by, look, now our expression will be del square U by del Y square. So if we integrate with respect to Y, then del U by del Y is equal to minus rho G Y by mu plus C1. And if we again integrate with respect to Y, U is equal to minus rho G by mu is constant into Y square by 2 plus C1Y plus C2. This is our expression for velocity profile. Now at Y is equal to 0, at Y is equal to 0, U is equal to 0. So implies C2 is equal to 0, yes or no? We need to find out C1 and C2 using two boundary condition. So C2 is equal to 0. And at Y is equal to H, isn't it du by dy is equal to 0? Because tau is equal to 0, the condition given is tau is equal to 0. Assume 0 shear stress condition at the free surface. It means tau is equal to 0, it means du by dy is 0. What is du by dy? This. So here du by dy is 0 minus rho g h by mu plus C1. So C1 will come out to be rho g h by mu. So our velocity profile, U is equal to minus rho g. Sorry, let me add one more slide. Give me a moment. Do you understand this? If anybody is having any doubt, please do let me know. So our expression is U is equal to minus rho g y square by 2 mu plus rho g h y by mu. This is our expression. U is equal to minus rho g y square by 2 mu plus rho g h y by mu. That is our expression. So at y is equal to h, U is maximum, that is U infinity. So from here U infinity is equal to minus rho g h square by 2 mu plus rho g h square by mu. So it will be rho g h square by mu, then 1 minus 1 by 2 or 1 by 2 into rho g h square by mu will be the answer for U infinity. Option A will be the correct answer. It will be option A which is correct. Acha. Is this clear? So this was the only question which was a little tricky. Rest of the questions were very simple. Question number 16. This is the question from the, this was the question from the manometry. Can you solve it? Question number 16. What is the answer? Everybody, a vessel which contains a volatile liquid and its vapor. There is a volatile liquid, there is a vapor. This is the vessel. Is connected with the mercury manometer. There is a mercury manometer connected here. As shown in figure, both the liquid and the vapor are at equilibrium. The vapor pressure is 107.6 kilopascal and the density of the volatile liquid is 700 kg per meter cube. The density of mercury is 13,600. Acceleration due to gravity is 10 and atmospheric pressure, this is open to the atmosphere. So atmospheric pressure is 101 kilopascal. Hydrostatic pressure created by the weight of the vapor is neglected. The value of H in meter round of the two decimal places of the mercury column in the figure is, if we write the pressure equation, starting from this point, here the pressure is vapor pressure. We are traveling in downward direction. It will be plus. We are traveling in volatile liquid into G into 1 meter. 1. So we can jump from here to here because these two points are having, these two points are joined by the continuous mass of same static fluid. So pressure here will also be this, and we can jump again. These 2 points are also having the continuous mass of same static fluid, and we can jump here as well. These two fluids are also having, these 2 points are also having the continuous mass of single static fluid. And now we are moving in upward direction to reach atmosphere. So minus, now we are traveling in mercury into G into H is equal to P ATM, or we can say rho of mercury into G into H is equal to P vapor plus rho of liquid into G into 1 minus P ATM. So 13,600 into 10 into H is equal to, what is the vapor pressure? Vapor pressure is 107.6 kilopascal. 107.6 into 10 to the power 3 plus density of the liquid is 700, G is 10, 700 into 10 into 1 minus atmospheric pressure is 101 kilopascal. 101 into 10 to the power 3. So this 30 getting cancelled out from here, getting cancelled out from here, getting cancelled out from here. So 136 into H is 107.6 plus 7 minus 101. How much is that? It will be 13.6. H is equal to upon 136. 0.1 meter will be the answer. 0.1 will be the correct answer using the pressure equation applying the Pascal law and hydrostatic law. Question 17 is very simple. Consider a fluid flow around an aerofoil as shown in figure. The direction of drag force. Drag force is in the direction of relative motion. Drag force is always in the direction of relative motion, and the lift force is normal to relative motion. If both the bodies would have been moving, they could have framed the question a little complicated by making both the bodies to be moving. But here this is fixed and only the fluid is flowing. So the direction of drag force will be this and the direction of lift force will be FL. So drag force is OB, lift force is OD, OB and OD, option A. Right? The direction of drag force and lift force. This type of question was also asked in engineering services. There the question was asked about bulk modulus, dimension of bulk modulus. It is having the same as the dimension of the pressure. So the dimension of the pressure, if you do not remember, then it is Newton per meter square. Newton is mass into acceleration into 1 by meter square. Meter and meter getting cancelled out. So pressure is kg per meter second square. So m1 L minus 1 T minus 2 will be the unit of pressure, dimension of the pressure, m1 L minus 1 T minus 2. B, it should not have carried 2 marks. It is not having the level of 2 marks. And one more information, we are running GATE 2025 and 2026 vision courses. And if you are interested, you can either fill up our counseling form, which is there in the description box, or you can call the mentioned number for getting more clarity about our paid courses. That question number 19, again NAT for 2 marks, very simple. The axial velocity profile of laminar, incompressible and fully developed flow in a circular pipe is given by. Generally we call the axial direction to be x direction, but they have used it like this. It is simply the velocity profile u is equal to u maximum into 1 minus, or we can write it as, if the expression is like this, 1 by 4 mu minus of del p by del x into r square minus small r square, or we can write it as u is equal to u maximum into 1 minus r square by capital R square. So this is u maximum, minus is taken here, del p by del x. So u maximum, radial direction, axial direction and axial direction, fluid viscosity and pressure are given. If the average velocity of the flow is given by this expression, what is average velocity? U maximum is equal to 1 by 4 mu into minus del p by del x into r square. Average velocity is half of maximum velocity. So it will be 1 by 8 mu minus del p by del x into r square. That is the average velocity for laminar flow. So K is equal to 8. It should have been 8. The value of K is 8. Very simple. Question number 20. From the model analysis, a 1/8 scale model of a car. So if we write LP by LM, prototype is the bigger part, P for prototype and M for model. P for prototype, M for model. If we write LP by LM, then we will write 8 by 1. If we write LM by LP, then we will write 1 by 8. That should not be a problem. Is to be tested in a wind tunnel. In wind tunnel or flow over the body is having the viscous force to be important. So we use Reynolds model. If the air velocity over the car, it means this is VP is 16 meter per second. What should be the air velocity in the wind tunnel? Air velocity in the wind tunnel. Model is tested in the wind tunnel. Actual car is moving in the atmosphere or moving in the air. So what is the velocity in wind tunnel in order to achieve similarity between the model and prototype? So if you read the question properly, then our question is to find out Vm. So if we apply Reynolds model law, according to Reynolds model law, because viscous force is important, Reynolds number is equal to rho VL by mu must be constant. Why we apply? Because viscous force is dominating. Viscous force is important. Density is same because wind tunnel is also having the air and outside is also air. Viscosity is also same. So V into L is constant. Right? V into L will be constant. So we can write VMLM is equal to VP into LP, or VM is equal to VP into LP by LM. Do not commit this mistake. LP is 16. VP is 16, LP by LM is 8 by 1. So it will be 128. It will not be 2. It will not be 2. It will be 128. B will be the answer. Question number 21, standard question. These type of question we always discuss in the classes. The velocity potential function in a 2D flow is given by, sometimes we talk about the velocity potential function, sometimes we talk about the stream function. The velocity potential function is given by this expression. The unit of velocity potential function is meter square per second. Always remember, A is 2, B is 0.5. The magnitude of velocity at x is equal to 2 and y is equal to 1 meter is. So we can say U is equal to, can we say U is equal to velocity in x direction is equal to minus del phi by del x, because there is already a negative sign. So what is differentiate the bracket with respect to x? So it will be ay plus 2bx, isn't it? And what about v? minus of del phi by del y. Negative derivative of the velocity potential function with respect to space gives the velocity in that particular direction. Because negative sign is there, differentiate with respect to y, then it will be a into x minus 2by. This will be the expression. Now at x is equal to 2 and y is equal to 1. A will be equal to 2 and b is equal to 0.5. So what is u? A is equal to 2, y is equal to 1 plus 2 into 0.5 into x is 2. So it is 2 plus 2, 4. U is equal to 4 meter per second. What about v? V is equal to again 2 into 2. A into x, a is 2, x is also 2, minus 2 into 0.5 into y, 1. So it will be 4 minus 1, 3. V is equal to 3 meter per second. U is equal to 4 meter per second, V is equal to 3 meter per second. So the magnitude of velocity is equal to under root of u square plus v square. So under root of 4 square plus 3 square, that is under root of 16 plus 9, that will be under root of 25. 5 meter per second will be the correct answer. It will be 5. Yes, Vinith, well done. 5 meter per second. And the last question was this, question number 22. There is a slight mistake here. The velocity in one dimensional flow is given by this expression. Meter per second square, meter per second. This is the expression. There is a square, b minus x square. This is the velocity. A is 8 and b is equal to 4. The acceleration at x is equal to 2 meter is. What is the acceleration? It is 1D flow. The flow is one dimensional. So acceleration is equal to local plus convective. What is local? Del u by del t. What is convective? U into del u by del x. Because u is not a function of time, the flow is steady. So this is 0. So the total acceleration, A total is local plus convective. So the total acceleration is equal to u is equal to A upon b minus x square into del by del x into A upon b minus x square. Do the calculation. So it will be A is constant, so it will be A square upon b minus x square. Now if you do the differentiation of 1 upon b minus x square, so it will be minus 2 into minus 1 upon b minus x cube. Yes or no? So the total acceleration is given as 2a square upon b minus x to the power 5. So if you put the value 2 into what is A? A is 8. 8 into 8, 8 square upon b minus x. B is 4, x is equal to 2. So 4 minus 2 is 2 to the power 5. 2 into 2 into 2 into 2 into 2. This 1, 2 is getting cancelled out. 2 to the 4 to the 8, 8 that will also get cancelled out. So then this will be 4. 4 meter per second square will be the answer for the last question, right? So these are the questions which had been asked in GATE Engineering Science Fluid Mechanics portion. I hope you found these questions to be very simple and you develop the confidence that how these questions are framed and how these questions are solved. So that is all from my side for the session. See you today at 5:30. I will have a session for ground zero series today at 5:30 p.m. on our BYJU'S app for hydrostatic forces part 2. Yesterday we talked about the hydrostatic force on a plane surface. Today I will discuss the hydrostatic force on the curved surface. Alright. So that is all from my side. Have a good day and a great career ahead. Thank you for joining in, and do not forget to like and share this session so it reaches to all the students who are preparing for GATE 2025 or other competitive examination. Alright, चलिए, थैंक यू वेरी मच. हाँ विनीत, ऐसा कुछ नहीं है कि मैं आपके जवाब से कुछ मेरे को फर्क पड़ा है, नहीं. There are so many ways. One of the simplest way I have found out to solve that question is the one which I've shared. That is what I meant. Alright, thank you guys. See you. Jai Hind.